640 light-years away, one star that was dying just erupted, and when it did, it hurled into space more substance than the gaseous and dusty equivalent of a few moons. No astronomers had ever witnessed anything like it before, and it may only be a precursor to one of the universe's most explosive events. For as long as humans have gazed at the night sky, one star has consistently captured attention: Betelgeuse, the brilliant red shoulder of Orion the Hunter. Betelgeuse is the reddish-orange winter hexagon star, and right now, it's going through something out of a forest fire-created apocalypse. Late in 2019, this celestial giant did something that sent astronomers into a tizzy. It began to fade, losing over 60% of its typical brightness. Suddenly, one of the brightest 10 stars in our sky appeared as though the dimmer switch had been turned down on it. Was Betelgeuse going to blow up? When a star such as Betelgeuse explodes, it goes supernova, expelling more energy in weeks than our Sun will have in its entire 10 billion-year lifespan. The supernova would shine so brightly that you'd be able to read a book in its light in the dead of night. You'd be able to see it during the day, blazing alongside the sun. But the explosion never happened. What happened instead was even more fascinating. With the infrared capabilities of the James Webb Space Telescope, we're actually getting to see what's really happening. And it's rewriting all we thought we knew about how massive stars explode. Betelgeuse isn't merely big, it's almost unimaginably huge. If you substituted it for our Sun, its surface would be outside the orbit of Jupiter. Mercury, Venus, Earth, and Mars would all be boiled away inside this monster. We're talking about a radius of more than 600 million miles. Light would take nearly 5 hours to travel across it. Betelgeuse is among the only stars for which we can observe the star's disk using telescopes. We can observe all other stars as shining points, but Betelgeuse is so large and relatively close, 640 light-years away, that astronomers can photograph storms on its surface using cameras, storms larger than our entire solar system. We call Betelgeuse a red supergiant. Its surface temperature is approximately 3,500 Kelvin, a mere fraction of the Sun's 5,800 Kelvin, but where it falls short in temperature, it more than compensates in good old-fashioned surface area, spewing forth light that's about 100,000 times more than our Sun. Large as it is, Betelgeuse is a spring chicken compared to the Sun, merely 8 to 10 million years old, but already it's nearing the end of its life. Red giants burn fiercely and burn rapidly. Betelgeuse, with a mass of approximately 20 solar masses, has been consuming its hydrogen fuel with reckless abandon. It began fusing hydrogen into helium, a process our Sun has been doing for 4.6 billion years. Betelgeuse did it in just under 10 million years. When hydrogen was used up, the core heated and contracted, burning helium into oxygen and carbon. The outer layers of the star expanded massively into a supergiant. But there's more. When helium was used up, the core once more heated and contracted, burning carbon, then neon, then oxygen, and silicon. Each time a fuel is used up, the core contracts, gets hotter, and burns the next heavier fuel. Silicon is being fused into the iron at the center of Betelgeuse. This makes a difference because iron fusion does not release energy, it burns it. When the core is largely iron, fusion will abruptly cease, and when it does cease, disaster occurs in seconds. October 2019, Betelgeuse began to dim. In February of 2020, it had dimmed to about 35% of its usual glow, plainly visible to the naked eye. The internet lost it. Observatories scrambled to point telescopes toward Betelgeuse. For several months, humanity speculated about whether we would see something that hadn't occurred in our galaxy for more than 400 years. A supernova close by. The Very Large Telescope showed us something interesting. The dimming had not been equal. The southern hemisphere had gotten much darker than the northern half. Something was in the way. Then Betelgeuse began to become brighter again in April 2020. By late summer, it was back to normal. So what was happening? Betelgeuse had, in effect, hurled some of itself into space. A bubble of hot, superheated gas, about twice as heavy as our moon, was blown off at thousands of miles per second. The material cooled quickly and condensed into a huge dust cloud that veiled Betelgeuse's light from the Earth. Solar outbursts from our sun are a big thing when they blast 1 billion tons of material. Betelgeuse's outburst was thousands of times stronger, blasting hundreds of billions of tons in what astronomers refer to as a surface mass ejection event. The James Webb Space Telescope views the universe in a way we can literally not. It's a 6.5-meter honeycomb of gold-coated beryllium truss pieces that gathers infrared light, capable of passing through dust clouds, which may stop visible light entirely. When Webb looked at Betelgeuse, it captured a star in utter chaos. Betelgeuse's surface is controlled by huge convection cells, places where hot plasma goes up, expands, cools, and falls back down. A single convection cell on Betelgeuse is big enough to contain our entire solar system, plasma clouds bigger than the orbit of Neptune, rising and falling in wild motion. The consequence is a star whose surface is perpetually violently agitated, a bubbling, boiling cauldron in which temperatures change by thousands of degrees. There are hotspots and transient hotspots. The surface boils and seethes like an outraged sea, comprising plasma evaporating. Webb's observations had confirmed that the Great Dimming was not a freak event. Betelgeuse periodically spews forth titanic amounts of material in violent, periodic outbursts. Inside, several layers of nuclear fusion shells generate immense energy, building pressure waves that radiate outward. By the time they reach the surface, they've ripened into high-pressure shock waves that accelerate plasma ahead of them beyond escape velocity, shooting gigantic pieces of the star's atmosphere into space. Astronomers thought for decades that red supergiants shed mass at a steady, stellar wind, a slow trickle of particles. But what Webb sees is a different picture. Material is cannon blasted out in explosive events that occur randomly over years to decades. Is Betelgeuse going to explode? The honest answer, we have no idea. The uncertainty is enormous. Betelgeuse is in its last stage. When its iron core becomes massive enough, it will burst into a state of instability. Fusion ceases, and unless there's some external pressure, gravity becomes dominant. The core shrinks from Earth-sized to city-sized within less than a second. Atoms are flattened. Electrons and protons coalesce into neutrons, spewing unfathomable quantities of neutrinos that push the star's outer atmosphere out into space at roughly light speed. When it does, Betelgeuse will brighten 100,000-fold or more, to roughly the brightness of a quarter moon. You'll be able to see it easily even during full daylight. It will cast shadows at night. It will be among the brightest objects in the sky for several months. But no one knows when now. Our simulations display any moment in the next 100,000 years. It might happen tomorrow or in 50,000 years. And if Betelgeuse did explode as a supernova today, we wouldn't be able to see it until 640 years later. The star we're viewing tonight lived in the late 1300s. The 2025 Betelgeuse is totally unknown until the light arrives. The chaos inside and outside Betelgeuse isn't causing destruction, it's the most innovative power in the universe. Each atom in your body that is heavier than lithium was forged in a star. The oxygen you're inhaling, the calcium in your bones, the iron in your blood were all star-smithed. Betelgeuse is doing that work today. With each explosion of material, it's fertilizing space with heavy elements. The cloud of dust isn't obscuring our vision, it's planting seeds of worlds to come. A few million years from now, when Betelgeuse explodes and its core spreads out over light years, this material will collapse into new stars. Some will form planets, some of those planets will have liquid water, and some of them might even develop life. That which will exist will be constructed of atoms that were once Betelgeuse. You are made of stardust, literally. Your atoms were forged in supernovaed stars billions of years ago. Betelgeuse is forging the stardust that will construct worlds of far-off millennia. Betelgeuse has been a fixture of human society for as long as we've been gazing up. Ancient Greeks thought it was Orion's shoulder. Arabic astronomers called it the hand of the central one. In Chinese astronomy, it was a general of war. It appears in science fiction everywhere, from Arthur C. Clarke to The Hitchhiker's Guide to the Galaxy. With Webb, we're writing new pages in the life of Betelgeuse, revealing secrets that the earliest stargazers may have only imagined. There is something intimate to us about witnessing Betelgeuse's moment of passing. We're the first human society with technology to actually observe, quantify, and comprehend this giant star as it dies. Betelgeuse is a stellar lab teaching us how huge stars are extinguished. It's a plant producing atoms to construct worlds to be. It reminds us that we are living in a universe constantly creating and destroying on scales beyond our imagination. Webb has treated us to the unrivaled spectacle of this star's cataclysmic last act. When Betelgeuse finally blows, the next year or 100,000 years, it will be among the most spectacular astronomical events in all human history. So go out tonight and glance up at Orion. See that reddish star indicating his shoulder. Recall that you are gazing 640 years back in time at a star that may well have already vanished. Recall that all the atoms of your body were forged in stars such as that one. If you liked this detailed video, like it, subscribe to Cosmogeist, and ring the notification bell. Leave a comment. What do you think will ultimately happen to Betelgeuse?